Okay, so let's start then. Hi everyone. First of all, thank you for attending to this presentation. My name is Victor Zanabria, and I will be your host for the next 45 minutes. So I really hope that you enjoy this session. So I will start with a short introduction about myself, and then we will jump straight to the presentation. I started to work in the world of IT around 9 years ago, and I have been playing different roles. But in this journey, I have always been focusing on the big picture of how things work, trying to understand the different ways of looking at solutions from an end-to-end perspective. And when I started to work with Kubernetes, this was not an exception. However, I had some close deadlines, so I had to jump straight to the practice. And I couldn't have enough time to be able to get a bit more deep into the details of Kubernetes. But after I've finished my first project, I was not fully satisfied. Therefore, I started to do my research to understand how Kubernetes work from within, how the different components interact between each other, and the results were really nice. Actually, I was very excited to understand what were the Kubernetes guys thinking when they designed this tool, and that's what I am going to try to do today. I'm going to try to share this knowledge with you, and I really hope that you enjoy this presentation. Once again, I would like to say thank you to all of you, despite all the different challenges we are having around the world with coronavirus and so on. You are still here, trying to learn some concepts and try to keep moving forwards. Okay, having said so, let's start. So first of all, where does Kubernetes fits into the world of computing architectures? Kubernetes, it's set in the middle between infrastructure as a service and a platform as a service. It's a hybrid tool. Therefore, you have to realize about this before jumping into the world of Kubernetes. It's not like an automated elastic resource that you, or like a function as a service that you can just write and let it there living for weeks and you will not even take a look at that. But it actually requires for you to take care of it and that you pay attention to it. So before jumping into that, I wanted to talk a bit about some of the things that one specifically thing that I has been a bit obsessed of, which is having had this dream of owning a pizzeria chain once. And when I was trying to learn Kubernetes, while going through it seemed to be quite similar, I think. But I'm going to try to explain you a bit what I was thinking when I went through this idea of owning a pizzeria. So the first thing that came into my mind was that of course I will be the founder. I will put the vision of it. However, I still need to have a CEO that runs the pizzeria chain, the one that I can just let him know what are my ideas. And of course, the CEO will not be able to do that by himself, but also he needs to have some support. So first of all, we have the Prescience team, the ones that take care of the things that no one else wants to take care of. Then we have a civil or an architect, which is the one who will be designing the pizzerias, the pizza stores. Then we have the civil engineer, the one who will be in charge of building this pizza stores, and he will be together with a security guy for taking care of our pizza stores. Then we will have our communications guy. Of course, what is it, a pizzeria without delivery? And finally, we have someone to take notes for our CEO. So, having said this, let's go a bit deeper. So the Prescience teams will be taking care of different things, and one of those things will be to handle the purchase of different areas where I'm going to build my pizza stores. I want to start from the scratch. And once they have been working on this, then the architect will come, and then he will start designing, depending on the areas, how is the best way to build the different stores. And this is more or less how a first draft of a pizza store could look like. You have the kitchen, you have an administrative accountability room, and then you have some storage. Not very, a bit not very practical. And both the civil engineer will make sure to build this, and the security guy taking care of that everything is working properly. However, we can have different options when it comes to the design of the pizza stores. You can have a kitchen within a store just to focus on the core of the business, which is cooking pizzas. And then we can have another one where we just have the administrative room and also the storage. Or we can decide to have only the administrative room in a single building, and let's move all the storage to the cloud. Let's make all digital to avoid problems. Okay. However, I can have also 3 models if I want. I can start with the first model, then I can evolve if the business goes well, if everything goes as expected. The idea is that here comes into the game the Telecom Guy, which will be taking care of all the communications, and all this will be done through telephone numbers. I know that nowadays we have more modern ways to do it, but like an application, an app, or similar. But let's say that we are a bit old style and we just want to start, so we don't have time to build an app. We just give them telephone numbers to communicate to the outside world and also to communicate between the pizza stores. All right. So I know that it's been already like 8-7 minutes, and you must be wondering how is all this related to Kubernetes. I promise there's some relationship. If you take a look at it, both are kind of circle, some kind of slices here. Yeah, so it has some similarities. But okay, let's see if indeed there are similarities or not. So when you deploy a Kubernetes cluster, okay, finally, Kubernetes. When you deploy a Kubernetes cluster, what you get is master node and one or more worker nodes, just to make your life easier and for not overcomplicate things. Let's take each of these nodes as virtual machines. This can be anything that, for example, this can be your smartphones, this can be your computers and so on. But for this exercise, and the most common way of understanding what is it a node is a virtual machine. So we always will have a master node and one or more worker nodes. In a master node, we have 4 components. The first one is a Kube API server, which is like our CEO, the one who will be on top, planning all the different kind of things that needs to be done. Then we have an etcd, which is like our node assistant. We have the Kube scheduler, which will be playing the role of our architects. we have the kube control manager playing the role of our operational team. On the hand of the worker node, we have the Cubelet, which is a mix between our civil engineer and our security guy. And then we have kube proxy, which is like our telecommunications guy. We will go one by one through each of them. But okay, so this was a cluster. And now we also have what we call the Kubernetes objects. The Kubernetes objects are everything that you can put in a Kubernetes cluster. We previously have been taking a look at the components that will do the job, but then what can be built are the Kubernetes objects. Nodes, we already saw them, and this will be something related to our piece of land. Pods is like our pizza stores. Services are like our telephone numbers. Volumes are like our physical storage, which it's useful to store information, but if there is some kind of a fire happening, then you can lose the information easily. And the persistent volumes is like having information digitally in the clouds, which is a bit more resilient, let's say. Okay, so let's start with the Kubernetes objects. First of all, let's start with our pizza store. Here is a bit tricky. When I remember when I started to work with Kubernetes, a lot of people were saying that a pod, it's a container. And that's what I had in my mind the first weeks where I started to work with it. But actually, a pod can be one container, a pod can be another container, two containers, and a pod can be two containers and a volume, or it can be more and more. It depends on how you design it. It's like your pizza store. You can have a specific room for the kitchen, the other one for the administrative duties, and so on. It depends on how you want to design it. You decide what to put in a pod. Now, when we saw previously, the most common way of using a pod is to have one container because it's a bit more organized to have one single thing inside a pod, as it would be much more organized to have only a single kitchen in a pizza store rather than having many things there. When it comes to the nodes, it's like our pizza stores area. It depends on how big it is, so that you can place one or more pizza stores. In the same way, it depends on the amount of resources that your node or your virtual machine have. So you can place one pod, two pods, three pods, and so on. And here we are taking a look at some of the attributes of the pods. Let's say the port, where you're going to get incoming traffic, for the container, and a label, which we will take a look later. Okay, so here we have the service. The service, it's a very simple but complicated at the same time terminology. In the simple way, it's like this. We have a use case that on the right hand, we have the Hawaiian pod trying to get in touch with the Italian pod. And what will happen is that we will have a service, and then the Hawaiian pod will call that service, and that service will make sure to redirect the traffic to the destination pod. And it works like the cell phone number that we were talking before. When you want to call to a pizzeria, you don't have the number itself. Well, if you have been consuming a lot of times, you have the name of the pizzeria, and then behind the scenes, a cell phone number will be dialed. In the same way, for pod 3 for the Hawaiian pod, he will just know that there is one Italian pod somewhere, and he just wants to have communication with that Italian pod. And behind the scenes, the service will make sure to redirect that to the specific IP address where this pod lives. Then we go to the Kubernetes volume. Here, a Kubernetes volume is an object where you can store information, and this volume lives inside the pod. So what will happen, or what could happen, is that a container can die, and if a container die, another container is created automatically, and then the container will have access to the information in the volume. However, if the pod dies, which is not very often, but can happen, then the container die, and then your volume will die as well, and all the information will be gone. And then you will have a lot of people very angry calling you at midnight, asking you, hey, we lost all information, what's up here? And you don't want to be in that situation. That's why we have the persistent volume. Persistent volume is an object that lives outside the pod. It lives outside the node. And what happened here is that the information, it's stored somewhere, depending on where are you hosting Kubernetes. Usually, if you are doing this in the cloud, it will be some kind of storage in your cloud provider. And then here, if the container within the pod dies, no problem. If the pod dies, no problem. Another pod will be created, another container will be created, and your information will still be accessible. Of course, here is much, as its own name says, it's more persistent, it's more secure, but you still need to do some frequent backups and so on to check that everything is working correctly. And this symbol here, storage class, is to specify what kind of storage classes what kind of storage class are you using. And as I said before, this depends on the cloud provider that you're working with. All right, so that was a bit of an introduction of Kubernetes objects. There are more. We have been taking a look only a few of them, but there are more than 40 kinds of Kubernetes objects. But yeah, it's impossible to cover those in one single session. So let's move to the Kubernetes cluster. Okay, as we saw before, then here we have five components that live both in master node and in the work node. If you remember, the first three live in the master node, and the last two live in the worker node. And there is one component that is missing that lives in the master node. Let's see if you remember before we go to the next slide. Okay, let's start with the first one, the CEO, Kube API server. So for Kube API server, what happened is that you, in the same way that you as a founder tell the CEO your vision, tell the CEO your desires, you do the same with Kube API server. You as a user tell Kube API server your desires. I desire to have a pod with the following characteristics, and then the Kube API server will make that happen. Or if you decide to have a service with the following characteristics, Kube API server will make that happen, and so on and so on and so on with all the different Kubernetes objects that you wish to have. This is called a declarative way of working. How Kubernetes can work in two ways: in an imperative way, where you tell Kubernetes step by step what to do, or in a declarative way, which you tell Kubernetes what is the desired status, what are your desires, and then Kubernetes will make sure to execute the steps to get there. Yeah, and all the different objects can be created. And the component that we were missing was the etcd. Remember the assistant, the one that is taking notes? That's the etcd, which is a key pair value database that stores every single action that the Kube API server does. Okay, let's move forward to the Kube Controller Manager. For the Kube Controller Manager, this is very funny. We're going to take a look at this. Remember the name, Controller Manager. So here we have Kube API server, and then again, we already told Kube API server our desires. And the Kube Control Manager is watching the Kube API server, watching all the different things that he has been getting. But Kube Control Manager, the creators of Kubernetes are very funny, as it's almost like in real life managers. if there is a manager in this webinar, please don't feel offended. But as in real life managers, the kube control manager do not do anything by himself, but he has a battalion behind him that will do all the work. So he will just be there on top, watching the Kube API server and then making sure that the desires that becomes true. So the Kube control manager he's watching that a node has been asked to be created, and then the node controller will come to the game and will create one node or will create two nodes. In the same way, if an Ingress kind of object was asked to be created, the Kube control manager will call the Ingress controller, and then the Ingress controller will make sure to create that object, and so on and so on and so on. With most of the Kubernetes objects, there will be a controller that will be taking care of the creation of these objects. This doesn't happen with the pods and the services. Those are not created by controllers, but apart from those two, most of the Kubernetes objects are created by a controller, which is led by the kube controller manager. Now we have the kube scheduler, which is our architect. Here, again, kube API server, get a desire about creating a pod. And then what will be happening is the kube scheduler is watching kube API server when a pod needs to be created. So when a pod needs to be created, the kube scheduler is watching the kube API server, and then what happens is that the kube scheduler will be taking a look at the different worker nodes that we have in our cluster, and it will pick the node that is the most suitable node to host the pod that we want to have. However, at this point, again, like the architect, he only does the design, right? When he designs, there is nothing created yet. It's just there somewhere in a blueprint. Here again, it's the same. Once the kube scheduler has assigned where a pod is going to be, then it's on this stage, but it's not created yet. And there is where our Cubelet, which is the mix of our civil engineer and the security guy, comes into the game. The Cubelet will be taking care of creating all these pods that have been placed by the kube scheduler. So the Cubelet again will be watching the kube API server, and he will see that a pod needs to be created, and then Cubelet will call our container runtime. In this case, there are different options. Kubernetes can work with Docker, CRIO, and so on. The most popular one is Docker. So he will call Docker for set up the container that is living within the pod, and then the pod will be created and will be up and running. On the other hand, the Cubelet also takes care of the monitoring part as our security guy. As here you can see, he will be monitoring that our work nodes are healthy, and if something wrong is going on, then Cubelet will act. And finally, before we get to the kube proxy, let's take a look a bit at how is the life cycle of a pod. So we said that we send the desire to the kube API server to create a pod. Then the kube API server, etcd is taking nodes. Once the node has been received, then we will be notified that a pod is going to be created. And then the kube scheduler comes into the game that is watching kube API server for a new pod that needs to be placed. And then the kube scheduler will do the binding of this pod into a specific node. And then the etcd will be taking notes of that. Then the Cubelet will be watching that a pod has been bound. And the Cubelet will make sure to call the container runtime so that the containers are up and running. And finally, the Cubelet will be updating the pod status, which will be noted by the etcd. And that's how the life cycle of a pod looks like. We have been taking a look at these different components, so I hope that now it's a bit more clear on what Kubernetes does behind the scenes. For us, we only are here telling the first instruction. All the other things that comes here is done by Kubernetes behind the scenes without us even noticing it. Now we go to the kube proxy. For the kube proxy, it's very interesting how the kube proxy works. Kube proxy is watching the Kubernetes control plane. Kubernetes control plane is the group that embraces all the components that we have been taking a look at previously. And also kube proxy is watching to the different services we have. So what happened is that kube proxy will make sure that these services are up and running and that they are redirecting traffic from one pod to another as it is supposed to be. In this case, let's say that the Hawaiian pod wants to get in touch with Italian pods. Then the service is taking care of that. However, it can happen that the pod dies and then there is no more traffic there. So behind the scenes, a new pod will be created by the Cubelet, that is the Italian pod again, and this might be created in another node. And here, our Hawaiian pod, he doesn't know that the Italian pod died. And here kube proxy have to make sure that the traffic is redirected to the Italian pod immediately, so that there is no connection. Try to avoid networking problems as much as possible. And once this happens, the Hawaiian pod will still be able to get in touch with the Italian pod, and Hawaiian pod will not even notice that a new Italian pod was created. So how all this happened behind the scenes? We have here the control plane. This is the first mode of working, which is the IP tables mode. Kube proxy can work in different modes. There are 3 nodes as far as I know, but maybe there are more. The IP tables nodes, how it happened is that we have our Hawaiian pod there trying to get in touch with one of the Italian services. Then the Kubernetes control plane wants to add a new service in order for Hawaiian pod to communicate with Italian pod. And what happens is that kube proxy will create this service. Once this is done, the Hawaiian pod will have to take a look at what we call a cluster IP. This cluster IP, it's a virtual IP that lives in the Kubernetes DNS. This cluster IP is going to be what we are going to get once the Hawaiian pod tries to do a service discovery. For Hawaiian pod, he will be trying to call Italian service, but then he will get as a reply from Kubernetes DNS that this service that he's trying to call has linked a cluster IP. This cluster IP is set in IP tables, and within the IP tables rules, this cluster IP will be linked to the physical pod's IPs with the label Italian service. So once we do the service discovery, we send the traffic to the cluster IP 10.0.171.239, and then the traffic will be redirected to one of the pods that are linked to that specific cluster IP. In this case, the way of how kube proxy does it is through a backend random selection. However, we have another mode that is the user space mode. Here again, kube proxy watching for the addition or removal of services. Service discovery happen, and then user space proxy installs IP tables rules which capture traffic to the cluster, to the service cluster IP. So again, Hawaiian pod do the service discovery, send the traffic to the cluster IP tables rules catch this traffic, and then for each service, kubeproxy opens a port randomly chosen in the local node. The IP tables rules redirect the traffic to these ports, and then kubeproxy proxies to the backend pod, which is selected via round-robin algorithm. Here's a bit different than the previous way of doing things. Okay. So that was kubeproxy. kubeproxy can work in different modes. We have been taking a look at two of the most common modes of working of kubeproxy. Now, let's take a look at one of the most important sections of Kubernetes, which is networks. Here we have the services we were talking before, and I'm going to get a bit more deep into the detail of the services. We're going to go through the three kinds of services: cluster IP, node port, and load balancer. And finally, we will take a look at Ingress. Ingress is not a kind of service, but it acts somehow as a service, and you will see why. So first, the cluster IP, we have a service that with type cluster IP with different kind of attributes. First, we have the name that is used for service discovery, as we saw in the previous slide with kubeproxy, and this name is mapped on the Kubernetes DNS, so that when the Lund DevOps pod wants to get in touch with the Vilnius DevOps pod, we do first a service discovery. The virtual IP, which is the cluster IP that will be matched with the desired pod's IPs, it's in the Kubernetes DNS. And finally, the selector identifies which pods will be linked to this service. Therefore, we do the service discovery first. Then, once we do the service discovery, we send traffic to that cluster IP. And depending on the mode of how kubeproxy is working, traffic will be redirected to any of the pods that have the label that has been specified in the selector right here. So that's cluster IP, that's the most common one. And now let's go to node port kind. Node port is used mostly for development purposes, and that is for exposing a service to the outside world. The previous one, cluster IP, is mostly for communications between pods. But what happens if we want to expose one of the services to be accessible through a web browser or a mobile app? Then what we do is we create a node port kind of service. And here, what will happen is that for each service, a port will be open in the node. And then the mobile app or the web application will send that traffic to that specific port, which will be redirected to the IP tables. And then it will be redirected to the pod we want to have access to. And same here, we want to access to that specific Vilnius DevOps service. And it could be that we are sending the traffic to another node where that pod doesn't exist. But we know that we have to send that information to the port 31579. And then when it goes to IP tables, the traffic can be redirected to the node where the pod is actually working. And that is all on the IP tables rules that have been defined by the kubeproxy. So kubeproxy is smart enough to understand that if traffic has been redirected to a node where the pod does not live, then he will find what is the node where this pod actually lives. And then we have load balancer. Okay, so that was for development purpose. As we saw before, that this can be doable. However, it's a bit ugly for the client to be typing on the URL the port where he is actually going to be redirecting the traffic That's not nice. Very dirty way of doing it. But when it comes to production environment, or when you want to really expose a service in a production way, you have to use load balancer. For load balancer, what it happens is that the cloud load balancer provider decides how to do the load balance, the request amongst the nodes. Here we have the kind of service load balancer. When we set up this kind of service in the cloud, a load balancer will be immediately set up. We just send our request to that specific IP, the load balancer IP, and then the load balancer will make sure to send that request to the IP tables rules, which will redirect the traffic to the pod that you want to get in touch with. However, here you can realize that if we have a replica of this pod, one living in a node 1 and the other one living in a node 2, it could be that the traffic can be redirected to the pod that does not live in the same node. And for this, there are different ways to solve it, like affinity rules, but you have to take into consideration that if you do this, you might probably be playing against the load balancing rules that Kubernetes have been setting up. However, one of the problems with this approach is that if you have more than one service that you want to publish, you will have to set up one load balancer per each service you want to expose. Let's say you have your web application and you have your API. Then having two load balancers, one for each of those, then can be a bit costly, unless you don't care about costs. But yeah, so not 100% convinced. And this is why Ingress was created. So Ingress is the most clean way to do this, let's say. How this works is that it works as a router, kind of, where you can specify different rules, transformation rules, routing rules, and so on. What will happen is that rules are set to define which inbound connections, which service routing, and then what will happen is that the load balancing depends on the Ingress controller. So here we have a load balancer, and the traffic will be sent to that load balancer, and the load balancer will go to the Ingress rules, and then the Ingress rules make sure to redirect the traffic to one service or to another. Normally, how Ingress works by default is that they get the traffic and then they send that to a specific service, as we saw previously. So they know the cluster IP of the service, and then they send the traffic to the cluster IP, and then the kube proxy starts to kick in. However, there are some Ingress controller providers that they have been talking about. Well, why am I going to go to the kube proxy? Why am I going to hit the cluster IP so that then we have some rules to apply and then redirect the traffic again? So what they have been doing is trying to set up the list of endpoints of all the pods that we have, and the Ingress controller itself, it's handling the rules so that traffic does not have to be sent to the services, but instead traffic bypass the services and is sent directly to the pods. So that's how some of the Ingress controller work, but the natural way is that it goes through the services, but it depends on how is that you want to set up your networking. And as you saw before, here you don't have to open a load balancer per each service that you want to expose, but you can have as many services as you want, your API, your web application, etc., using only one single load balancer. And then the Ingress will make sure to redirect the traffic. Okay, then as a summary, we have been taking a look at Kube API Server, Control Manager, a Scheduler, etcd, which lives in the master node. Then on the right hand, we have Cubelet and Proxy living in the worker nodes, which are watching the master node. And then there are different kinds of services here at the back, type node port, cluster IP, load balancer, Ingress, which is not a service, kind of service, but acts somehow like a service, which everything ends up in IP tables rules that in the end are redirected to a specific pod. So I think we are on time. So thank you. That was all from my side. And then if you have any questions and answers, you can go to this Slido that I show at the beginning. If you don't know about it again, I will try to display it. So Q&A and Slido with DevOps 2020. So let's see if there are any questions. Okay, good. Let me see. How suitable is Kubernetes is for on-prem production setup? Manager node setup seems very complicated. People often use Minikube. I doubt that can be used for production setup. Yeah, very difficult to set up Minikube for a production environment. To be honest, I have been working mostly with Kubernetes solutions that are hosted by a cloud provider. I have been working mostly with Google Cloud, and I have seen a little bit of how it works with AWS as well. So I'm not sure how Kubernetes will work in production if you set up it yourself on-prem. But I think the most used way around different industries and many companies is that they go with a cloud provider. And the other one is also load balancer and Ingress setup on-prem looks painful. Yes, that is true. As I was explaining before, when you are setting up a load balancer kind of service on the cloud, a load balancer will automatically be created for you. You don't have to do anything. And the cloud provider will make sure that the load balancer is suitable for your Kubernetes cluster. Besides, they have been testing their load balancers, like, I don't know if the details for AWS, but for instance, for Google Cloud, I think it's 1 million requests per minute that you can receive in a single load balancer. So yeah, I would definitely go for a cloud option if I would be you. Have you ever considered using OpenShift? I have think about that, but I haven't had the chance to go with OpenShift, but it could be an option. It could be an option depending on what is your use case. So we have 1 more minute for questions. And let's see if we have any other question. Otherwise, is it viable to deploy Kubernetes master and worker on same host? I'm not sure what I mean when you say on same host, but by default, a master, the master node will be deployed in a different virtual machine than the work node. And this is quite cool because what happens is that if your master node dies and it lives in a virtual machine that is completely separated from your work node, then yeah, the master node can die, but all your services will be still up and running. So there is no problem with that. And that's that's one of the main reasons why the master node is not in the same place than the worker node. Is it true that in AWS, when I use EKS, I do not have any ever see if the master as it is managed by AWS itself? If it depends. I don't have an Eversea, if the master is as it is managed by AWS itself. Yeah, I think I have seen something like that. As I was saying before, I have been mainly working with Google Cloud, a little bit with EKS. So I'm not sure. The times that I tried with AWS, I was using COPS, which is kind of an old project, and with EKS a little bit as well. But I am not sure about this Eversea thing that you are mentioning. Okay, so I think time's up. Thank you very much. I hope you enjoyed the session. And if you have any more questions, just go on my LinkedIn that I share with you, and then we can have a chat there. Thank you very much, and see you another time. Have a nice afternoon, evening. Bye-bye.